Okay, in the following series of videos, what we're going to do is review some of the code that we use to generate the simulated adaptation data that we discussed earlier. So there are 4 separate files that we use for this analysis. One file generates the data. The second file combines the data across participants. The third file summarizes that data, so computes summary measures for all participants. And then the fourth file does some of our statistical analysis and creates some of our data visualizations. So let's start at the beginning here. I'm going to clear my workspace. So first we're going to open this file S1 simulate adaptation data. So when I double click on the file, it opens in my editor. And just as a reminder, some of you may have your editor docked, which means that it would look like, let's see, this. So it would show up within the main MATLAB window. I generally don't like to do that because it makes it difficult to read the text. So if you want to undock the editor, you can select the down arrow and then undock. Okay, so as we've already reviewed in our early video on data processing pipelines and fundamentals of data, there's a long description here about the type of task that we're simulating and the model used to simulate the data. But for now, what I want to do is to walk through some of the details of the code to highlight some aspects of code that you may use in your own data analysis pipelines. So first, if we scroll down to line 31, you'll see a line of code that starts with mkdir space and then simulated adaptation data. So as you're performing data analysis, there may be cases where you need to create folders to store the results of your analysis. And so mkdir just stands for make directory, and this will store or create a folder within your current folder. So just to review, there are a couple of things that we want to keep in mind when trying to either integrate data into our analysis pipeline or save data to specific locations on our computer. So if I go back to my main MATLAB window, again, we will reinforce this probably multiple times because this is can be a tricky bit for new people who are new to programming. You always want to make sure you know the location where you are in terms of your current folder. So if I use that make directory command, it will create a folder within this long path that I have here, right? So my adaptation simulation folder located under MATLAB, week 4, repo, rehab, and so on. Okay. So let's go back to our code. If we look at our current folder, we'll note that there currently are only 4 MATLAB files. But now what I'm going to do now is actually highlight the code from line 28 through 31, right click, evaluate selection, and if I go back to my current folder, I see now that I have this new folder. Okay, so that's just the outcome of the make directory command. So now, what would I like to do next? So one thing that you may want to get into the habit of doing is doing what's called pre-allocation. And that is a useful way for you to set aside memory on your computer for MATLAB to store data and the output of your calculations. So for instance, I know I want to create a variable called true parameters that will be where values will be added to that variable as I go through my for loop. And I know that I'm going to do this 16 times, and I want this variable to have 4 columns. And actually, I'm going to change this to n_participants. Okay. So this is actually a variable that is the input to my function up here at the top. And so I want the size of this variable, true parameters, to correspond to the number of participants whose data I'm simulating. So one additional note, so after we made our folder, we also created a new variable called home, and this just tells us or allows us to store in MATLAB's memory the variable that corresponds to our initial directory. And so that's just something we'll come back to throughout the, within the for loop. All right, so we discussed pre-allocating space for, in this case, a couple of variables here. Whenever I make figures, I like to open a figure window by itself and then add information to that later on. So the core of this first script, or this function, is that we're going to go through a for loop and generate data for different essentially synthetic participants. And what we're going to do is we're going to mimic what we would do if we were saving data from an actual experiment. In other words, for this case, we're going to save data for each participant in a separate folder. So what I want to do in my for loop, so I have we would call this our looping variable, so the variable that changes every time we go through the for loop. This variable starts with a value 1, and then it iterates until reaching this value in participants, which again is specified as the input to our function. So in other words, if we were going to simulate 10 participants, then this variable participant underscore num would start at 1 and be updated through the for loop until it takes on a value of 10. Okay, so what we're going to do is we're going to, within our for loop, we're first going to move into the folder that we created, the simulated adaptation data folder. And within that folder, we're going to create several subdirectories, one for each of our simulated participants. Now, to create a consistent naming convention, as we've mentioned before, we're going to use an if statement that varies the number of whether or not there's a leading 0 in our participant ID number or not. Right? So if our participant number is less than 10, so a single digit, we'll add a leading 0 to the folder name. Otherwise, we won't. And that just makes sure that, assuming we have less than 100 participants, that all of the folder names have the same number of digits. Okay, so this is going to simplify our analysis later on. So again, we use our make directory command. And this time what we do is we're updating the name for the folder as we go iterate through the loop. So how are we doing that? So we're going to create, this will be a character vector or character array, where the first part of this has the leading sort of letters and numbers of our folder directory or folder name, right? So we want this to be consistent. There's some date, information, and then the subject ID. And then the second thing that we want to do is we want to update the actual participant number every time through the loop. So how are we going to do that? Well, first, we of course know that we need this variable participant num, and that's the one that's going to change as we go through our loop. And because we want to combine this with a set of text, we need to take this number, so a numeric value, and convert it, in this case, to a string. So the function num to string is going to create or convert the number, in this case, number 1, if we're on the first time through the loop. It's going to take that number, convert it to text, so that we can combine it here. Okay. So let's just show an example of how this works. Okay. So I'm going to copy this, and we're going to take an example in our main window where in participants is equal to 1. Okay. So as you can see here, we have this is a double, so it's a numeric variable. And now we'll show how you can build the name of our directory. So now we can take this whole vector here, so starting with the square bracket, starting and ending with the square bracket, you can copy this line of code, this bit of code, paste it, and now we can see so we have an error. We actually meant to make this participant num. Now we should be able to combine this, and so now we can see that we use num to string, it takes this num1, this value 1, converts it to text, and then appends it onto essentially the prefix that we've established here. Okay, So we're spending a bit of time going through this because this is a really useful way to code, to create directories or move through directories that have at least a consistent naming format. You can imagine this would be much more difficult if the folders had arbitrary names, different numbers of characters, and so on. Okay. All right, so the rest of the code, or the key bits of code here, we won't spend too much time reviewing unless people want to go into detail later on. But here's a way that we are creating a random set of data where we use some of the random number generators in MATLAB for that purpose. So for instance, if we want people to take varying numbers of strides like they would in an experiment, we can use rand_i, which generates random integers that range between a start and an end value. So those are specified here. And then 1 and 1 specify the dimensions. So for each time we go through the loop, we're just going to generate one random integer between these two values. We're then going to create a vector that corresponds to starts at the number 1 and ends at however many total strides. So this just allows us to sort of count the number of strides. Then we're going to generate some random parameter values for our model. So here is an example. This line of code is quite useful, where if we want to generate a random number that has some range, we can use a couple of things. So first, we're going to specify the average value. Okay. So we're going to say, well, for this parameter, we think on average it should have a value of -0.05. Okay. Then we want to generate a range of values around that. So we're going to create sample values from what's called a normal distribution. And so this specifies the mean of the distribution, and then this code will specify the standard deviation of that distribution. So if the wider the range that we would like, the larger this initial value should be. Okay. So the function rand is going to generate random values between 0 and 1. And so if we do rand and then subtract 0.5, now we're going to have values between -0.5 and +0.5. Okay. So you can kind of work through this to see what range of potential values we can get for this parameter. All right, so the last few things to keep in mind here. So there are more lines of code where we actually generate our random values, our simulated data. So that's particularly these lines of code. One thing you'll note throughout this code is that you'll see, a space, 3 blue dots, and then another line of code. So whenever you have a really long line of code, let's say like this is just a matter of personal preference. All right, so this would be equally valid. So this will be a single line of code, but personally I like to keep all of my code as on a single page, where this vertical line would specify the end of the page. Okay, so that's just in case you want to print it out, which is really helpful when you're going through someone else's code. So I can just find the point where I'd like to start a new line, 3 points, space, enter. Okay, so the last few things here. So we're going to create a figure that you saw earlier, and that figure has multiple rows and columns. And we use a function called subplot for that purpose. Subplot takes 3 main inputs. The first input is the number of rows. So in this case, I have a line or a bit of code that varies based on the number of participants. So I'd like this figure to be square, to have the same number of rows and columns. And so I want to make sure we have no less than the minimum number of rows and columns that we need. So to do that, imagine that we have 16 participants. Well, in that case, we know we need 4 rows and 4 columns. So the number of rows is actually equal to the square root of the number of participants. Well, what if we had 17? Well, there we know we need 1 more row to have that 17th participant. And if we want our figure to be square, then we would also add 1 more column. And so one simple way to do that, to figure out how large that number should be, is to take the square root of the number of participants, okay, and then use the CEIL or ceiling function, and that just rounds up to the nearest integer. Okay. So in the example of 17, we know the square root of 17 is going to be a little bit larger than 4. So this will round up to 5 and give us 5 rows, and then with our second input, 5 columns. And then the last input to subplot tells MATLAB which of the elements in the figure or which of the axes to use. So in the subplot function, the axes are numbered from left to right, top to bottom. So if this were 3, this would be the 3rd column on the 1st row. And then finally, we plot our data. So once we create our figure, we then go on to save the data. So we actually export data into a CSV file. And we can do that using a function called write-matrix. So for this function, we tell it which data we'd like to save. And then we specify, let's hover over again, let's see. We specify the second argument to write-matrix is the name of the file. So just like we did earlier when we created new directories, we can update the name of a file every time through the loop by creating a long character vector that has the name of the file. Okay. And then finally, we go back to our initial home directory, right, which is the simulated data, and we do this again for all of the participants. Okay, so those are the key features of this first script. There are some other details within there, but you can hopefully search for the functions in MATLAB to get a sense of what they do, but now you should have a good overall understanding of how we simulated this data and created directories and file names programmatically. All right, so next we will review the second bit of code here. And what this is going to do is going to cycle through those folders to combine our data into a single structure.